We hope everyone's having a great day and welcome. We'd like to talk about a new design win and solution we're really proud of. We worked on this build with our friends at Altera and Napatech, and the support we've received during product release has been fantastic. But first, a little background on why you should care. Network servers and applications are swamped with data, and it's no surprise because 90% of the world's 28 zettabytes in 2024 is redundant and largely unnecessary. Why? Because only 10% of the data is actually unique. The rest are just copies. And the data copies aren't arranged in a way that maximizes customer investment. They add unnecessary delays, and they bog down application servers. Now, we know that cold or at-rest data is highly duplicated, replicated, and copied for other data silos pretty frequently. There is, to my knowledge, no demonstrable use for the much more expensive data babies that occupy your most expensive assets like CPU and memory. While it's no fun to write a check for a $6 storage asset that is only properly used 10% of the time, it makes even less sense to pay $1,000 for up to 16 concurrent CPU, memory, and network copies of that data, especially when they're easy to eliminate. This remedy reduces overall operations, energy, software, and hardware cost, while also making applications much faster. The problem I'd like to discuss for today is logs. Every enterprise in existence uses system logs, telemetry logs, and other log-derived analytics to monitor system history, usage, and to look for cyber attacks. Multiple teams consume these logs from IT operations to security to DevOps and leadership. So it's very important data. The problem is customers are currently forced to choose between bad and worse when it comes to how to share this data. And that leads to millions of duplicate data records per day of operations. Go ahead. Ask your customers if they think they are getting fair value for their Splunk spend. Every time we ask that, the question is always the same. There is too much duplicate data, and it's costing us way too much money. We go to market with Splunk, so I'm not picking on them. Please recognize that the duplicate data exists no matter what tool you use because the data layer itself is flawed. The bad version of a log config is paying a cloud analytics provider 3x of what you really owe because of all the duplicate data in a consumption-driven model of pay-by-the-drink cloud analytics, while also bogging down production enterprise systems with infrastructure overhead tasks such as connectors. It makes it even less desirable. A worse version is not paying them and just creating local or centralized system logs. Assuming they can access the data at all, because a flat log is a very bad user experience, there's also a limited utility in deliberately stuffing data into an append-only log. These systems are crying out for a streaming data solution that sends users alerts instead of flooding them with unoptimized data that gets copied again and again. The other problem with sending data to SaaS analytics providers in the cloud is that what you need to send up for analysis is a small subset of all your log data. An example might be, do you really need to analyze millions of DNS resolutions per day and pay to store those items? You see, if it's directly connected to cloud analytics at the per server level itself, you can't eliminate the duplicate data, and then you have no control over your consumption-driven costs. So what happens if you guessed wrong on projecting the quarterly costs for, say, Splunk, Elastic, or Datadog? While the lower cost option of not using a cloud provider is far more cost-effective, it has its own issues. So if you wanted to create a honeypot for intruders, here's exactly how you do it. Aim all of your system logs at a central syslog repository, and control access to it using only system-level permissions instead of role-based access controls. So isn't there something better? How about optimizing data for compute and transport while reformatting it to reduce the most expensive data copies? How about zero-copy data that can be computed where it sits without crossing the network at all, instead of 16 copies at $1,000 per copy? How about sending the data to a modern pub sub so alerts can be streamed directly to users who can self-filter their own alerts based upon their role and their interest level? How about also wrapping the optimized data so you can leverage hundreds of open source AI/ML models for free right at the point of ingest? Well, this is what we do at SigmaX. Our data solution eliminates dozens of the most expensive data copies. These are the $1,000 in memory and on CPU copies, not the $6 cold storage copies. We also cut cloud analytics costs and allow the user to manage what gets copied, down to the per stream and per topic level. Additionally, we place a cryptographic boundary around streams so that they're protected from bad actors and external threats, but also so multiple business units can share data while keeping role-based access controls firmly in place. The problem we really need to solve happens much earlier in the data lifecycle than you'd expect. Data scientists, managers of data warehouses, and ETL will all tell you that they spend 90% of their time doing data prep. The fun part, the AI/ML, and the modeling work is very short compared to the data prep phase. So in our demo today, here's what you'll see. First, we use the IPA's FPGA to reformat the ancient data standard RFC 5424 syslog messages to Apache Arrow, and we do that in about 128 nanoseconds. This conversion works for any systems that support that RFC: Linux, Windows, VMs, containers. Apache Arrow data format then allows us to eliminate 80% of the wall clock compute time when users consume data, but it also allows us to place the data in an AI/ML ready data frame on the IPU itself. Once the data is optimized for real-time compute and network, we then publish the outbound data in batches of records to our pub/sub system to share with all permitted users. A secondary benefit of using this approach is that you can replicate as much or as little of this data to a consumption-based cloud analytic. But it also occurred to us that the IPU as a server and server config is an incredibly good configuration for a very dense but very capable general-purpose Apache system. Notice that we're saying Apache and not just the pub/sub called Pulsar. Because we can remove lots of unnecessary duplicate data, we reduce customer spend on cloud analytics by around 50%. Our world record for parsing JSON demonstrates we have 100x better latency than the next fastest open source solution. Apache Arrow data format, the format NVIDIA uses for GPU data but they call Rapids, provides the wall clock improvement of 80% when compared to a traditional database. And using FPGAs to do this real-time conversion work means that using 5% of the energy cost of a full rack mount server, and it includes the higher level TCP protocols we require on a single device. A recent customer example program for the US Navy showed us outperforming their prior build by 57x in terms of message rates using our optimized pub/sub. So now in our first demo, we show our partner engineer using FPGAs to emit Apache Arrow record batch instead of 1980 syslog formatted data from an FPGA to the SoC. This is an invisible step for customers and requires no engineering steps beyond the initial configuration. After that step sends Apache Arrow to the SoC, using that on-network data to visualize log analytics using the now optimal data consumed directly from the pub/sub. But we also show the Arrow flight SQL tables that are now available on the SoC. And that concludes our video demo for today. Please stop by our booth or contact us via email for any follow-up questions. Thank you very much.